we need to use waveform symmetry and find the Fourier series coefficients for our periodic waveform. Now what I have up here, this is the normal way we would find it if we didn't have any symmetry. Now even if we have symmetry, we could still use this. However, since we have symmetry, we're not going to use this regular way. When we look at this, we can see that our period goes from this -2 right here to the 6, right? And then it keeps repeating on after that. Well, from 2 to 6, we have symmetry right here. And from -2 to 0, we have symmetry, or actually, well, I'm sorry, it's from -2 to 2. We have symmetry across this, right? And it's even symmetry. That's important to note. Since it's even symmetry, this is what we're going to use to solve for it. Now, even symmetry, we can clearly see that our b of n, which is also b of k, is going to be equal to 0. So this is 0 for all k. Now, before we continue on and find our AV and AK, let's find our omega and our f. So omega, we know is in rads per second, and the formula for omega is equal to 2 pi over t. Now our t is the period. So our period goes from -2 to 6. We cannot just put 6 though, because the period is the total distance between it. So this t is 8. Since we're measuring in microseconds, remember this is 8 times 10 to the -6. That's super important to note. If we plug this into a calculator, we're going to get 7.85398 rads per second. Now we have our frequency in hertz. We know that frequency is equal to 1 over pi. And pi is our t. And so our t is 8. We're going to have 1 over 8. But remember, it has to have this times 10 to the -6 because we're in microseconds. And so we're going to have 125,000 volts. Or I'm sorry, hertz. Frequency is measured in hertz. Now we can look at the other stuff. So we're going to start out with our AV. Now, our AV is going to be the first one. So we're going to say AV equal to 2 over t. And now we have to deal with the integration. So we can see that our integration changes levels right here. So we're going to be going from -2 to 1. And this is from 25. This is our f of t, right? Our f of t is this right here. And so this is going to be dt. And to this, we're just going to add, we're going from, sorry, this should be a -1, -1 to 0, right? Because we have this part right here. And then we're going to have a 50 dt. Now, this is going to be reflected across here, so we don't have to figure that out. That's what this 2 does out front right here. Now, you're going to ask, well, okay, now we do this part, right? Well, since it's 0 across this entire part, we don't have to look at it. So we're only going to be looking at this part. So let's solve for this. We're going to have a 2t on the outside. And in fact, let's factor out a 25. If we factor out a 25, inside of here, we're just going to have a t from -2 to -1 plus a 2. And then we're going to have t inside of here from -1 to 0. So this is that. And now we can start plugging in our values. So we're going to have 50 over t. And then inside of here, we are going to have a -1 minus a -2. So these are going to be added together. We're then going to have a plus 2. And then inside of here, we have a 0 minus a -1. So it's going to look like this. So inside of here, we're going to have a 2. And this is going to give us a 1. So we have 1 plus 2, which is going to give us 3. We know that t is our period and t is 8. So inside of here, we're basically going to have 50 times 3 divided by 8. And this is going to give us approximately 18.75 volts. Now, we lastly need to solve for our AK. Now, our AK, when we look at this, we're going to say, okay, it's basically the same thing, right? Except out front, we have a 4 over t. And then inside of here, we're still going from -2 to -1. We have our 25 out here. But we need to multiply this by a cosine, Rn, which we can also write as k, omega naught, which you can write as 2 pi over t times little t, and then dt plus, inside of here we're going to have a negative 1 to 0. We're going to have 50 cosine, and then inside of here are k 2 pi times t over t, and then we're going to have our dt. So now we need to take the integral of both of these. I'm also again going to factor out a 25. So we're going to have 25 times 4. It's going to give us 100 over t. And then inside of our integration, we are going to have a sine. We're going to have the k 2 pi times little t over, and we'll just put this as 8 because we know t is 8, right? So let's just start making all the variables the same. And we're multiplying this by our t, which is 8, divided by k 2 pi. And this is going from negative 2 to negative 1. We then have plus, we have this 2, we have the sine, and this is essentially going to be the same. So we have k 2 pi times little t over 8, and this is being multiplied by our 8 times k 2 pi. And then we can write this as a negative 1 to 0. So this is our equation now. We can combine these two. We're going to have a 4 right here. This is going to give us a 4 as well. And then this will give us a 4 here. And then we're going to have a 1 over 4 inside of here. So now we can rewrite this, factoring out the 4's, right? We're going to factor out 4's here. And we're going to also plug in our values. So we're going to be doing a lot here. We're also going to be factoring out this k times pi. So out front, we're going to have 100 times t, or divided by t. We know t is 8. This is being multiplied by 4 because we factored out the 4. And then our k times pi. So this is everything out front. Now inside of here, we're going to plug our values in. We're going to have sine, right? We're plugging in the negative 1. So we're going to have a negative pi times k over 4. And then I'm actually going to move this down because it's getting a little bit close to our previous equation. Next, we're going to plug in our negative 2. So we're going to have a minus sine. Plugging in the negative 2 here, we're going to get a negative pi k over 2. So very similar. And now let's deal with the next part. We're going to put our 0 in. We know sine of 0 is just 0. So we're going to have a 2 times 0 here. We're going to have a minus 2. And then we're going to plug in our negative 1. And that's going to be the same thing as our first one. So we're just going to have a sine minus k times pi divided by 4. And so this is our new equation. This is going to 0 out. And now we can combine some things. So this is going to be halved. We are going to have a 50 over pi times k. And then inside of here, we are going to end up having, if we combine this with this, a minus sine, then a minus pi times k over 4. So that's what that's going to be. And then we are also going to have the minus sine, and then we have our minus k, or pi times k over 2. Now, we have these negatives inside of here, right? And since we have these negatives out front, well, these negatives can combine together. This will be a plus if we make this a plus, and this will be a plus if we make this out here be a plus. And that's just how, if we were to look at this and we plug it in, how if we get a negative number with our sign, well, the negative out front makes it a negative, so it's going to be over here, which is a positive, right? And so we'll just have positive all around since we're going to be here anyways. That's why everything is positive. So when we look at our answer, we have a of k is equal to, and all we need to plug in here is the 50, and everything else is filled in for us. So that's how we would look at this problem.